Hi there, and welcome to today's chemistry class. For this class, we will dive into the concept of molarity. So let's discuss molarity and also the mathematical expression for molarity, and then we'll solve several past questions in the study of molarity. First things first, what is molarity by definition? Molarity can be defined as the ratio of number of mole of a compound in a liter of a solution. So that's a definition for molarity. It is important to note that molarity, molarity is also called mole concentration, mole or perhaps molar concentration, or perhaps we call it what? Concentration. So note that there are three distinct names for molarity. Then you call it molarity or molar concentration, or perhaps concentration only. So these are the names for molarity. So having understand definition and the several names molarity can come, let's look at yet the mathematical expression for molarity. So mathematically, we're saying that molarity observe please, we're saying that molarity is equal to the ratio of number of mole of a compound. That becomes your mole of a compound over the concept of volume there, that's volume. So note that molarity is simply the ratio of what? Mole and volume. As easy as this, please. So let's get the S sign for molarity. We said mole is MOL, volume of course in liters. So I'm saying now that the SI unit for molarity is what? Mole per liter. So if I give you a question and in the question I gave you 5 mole per liter, that 5 mole per liter signifies what? The molarity. So this becomes your mathematical expression for molarity. So mole over volume. By the way, before we proceed with solving problems involving molarity, I already explained the concept of mole in our previous classes. So watch out the previous video on mole. I'll drop a link in the description of this video, a link to mole. That will give you little basic understanding before you dive into molarity. So do well to watch our video on mole before you dive into molarity. But for understanding sake and for teaching sake, I'll try to explain mole as possible as I can before we proceed in solving problems here. All right, let's look at mole. Let's discuss mole a little bit before we proceed. So by definition, a mole of a substance is the amount containing as many elementary entity as the number of atoms in carbon-12, right? So that's your basically definition. So leave definition for definition's sake. Let's look at the major priority here. First, the major focus here is to record the mathematical expression for mole. So I'm saying that mole, mathematically, for mole, mole is equal to mass over what? The molar mass. So mole is what? Mass over molar mass. Molar mass is also referred to as relative molecular mass of a compound. So this the key concept I want you to note when it comes to mole. So in case you are asked to perhaps, okay, when we start solving problems, you see why we need to understand mole, and note that mole is mass over molar mass. By the way, mole can also be expressed as the ratio of number of particles over Avogadro's constant. If you're familiar with my previous video, you should know all this. All right, let's take a break here and let's start solving several WAEC, JAMB, and institutional past questions, and let's see what we get. Welcome back. So let's dive into solving problems involved in molarity. So first, example 1 says, what is the molarity of a solution that contains a 0.35 gram of beryllium fluoride, that is BaF2, in 0.50 liter solution? Take the atomic mass of beryllium to be 137 and take the mass of fluorine to be 18. So let's get it done, please. So first, you were asked to find molarity. What is the molarity, right, of a solution? So first, solution here. We are asked to find molarity. What do we know? Solution. In this case here, what is molarity? First, molarity. So your first task in science is to list out the given parameters. What are you given? So molarity is unknown. Next up, of a solution that contains 0.35 gram. If I have 0.35 gram, that gram there signifies what parameter? Of course, mass. So I have a mass of what there is 0.35 gram. Next up, of beryllium fluoride BaF2 in 0.5 liters. If I have 0.50 liter, the liter there signifies a parameter which is known as what? As your volume. Alright, I'm given volume to be equal to 0.50 liters. Alright, so I'm given a mass number of beryllium and fluorine. Alright, for me, please, let's get molarity. What do we know from general? We know that molarity is equal to number of mole over molar mass. Over volume, please. Over volume. Alright, this is molarity as I established earlier. So first there, we are asked to find this man. To find molarity, I need two things. I need mole and volume. Help me check up here. Am I given mole? Of course, I don't have mole here. Am I given volume? Of course, yes, there's volume. So my task now and responsibility now is to find mole. Let's get mole, please, from this formula here. But we know that this mole is what? Mass over what there? Over molar mass. Alright, look up, please. From here now, let's get mole. Are we given mass? Of course, I have a mass. Molar mass. By the way, when it comes to molar mass, molar mass is boils down on the compound you are given. I'm given beryllium fluoride, that's BaF2. So let's try to get molar mass and then we'll put the value here. So for molar mass of the compound, which is given as BaF2. So what's beryllium? Of course, 137. So I have 137 plus fluorine is 18 times 2. All right, I have this. This is now equal to 137 plus 8 times 2. That's 36. All right. If I'm to add this together, I'll have about 3 here, 6 here, 163. All right. I'll have a 163 here, gram per mole. This becomes your answer for molar mass. Let's now get mole. Of course, mole from here, mole is equal to, we said mass first. Check the question here. My mass here is 0.35 first. So I have 0.35 over, next up, molar mass. We already calculated for molar mass as what? 136. I have 163. From here, mole should be equal to, if I'm punch my calculator from here, if I'm to punch calculator from here, of course, if I have, hold on please, I think 173. This is 173, please. This is 173. Not 163, please. 173. All right. If you add that together, you have 173. All right, let's get mole here. So I have 0.35 divided by 173. All right, I have about 2.023 times 10 to power minus 3. Please, if I have mole, what's the essence for mole? That's MOL. So MOL. All right. We're not asked to find mole, but what the molarity. So I've gotten mole now. Let's now get molarity. So recall that we said that molarity, this man here, molarity is equal to mole, and mole is what there? 2.023 times 10 to power minus 3 over next of volume. Volume there is what? 0.50. 0.50. Of course, let's get final answer for molarity. All right, molarity will be equal in value to 0.50. Yeah, so I have about 4.046 times 10 to power minus 3. Please, what will be my SI unit for molarity? We said for molarity there, the SI unit is measured in what? Mole per liter. So of course my answer should be in mole per liter. This becomes how to solve problem involved in the concept of molarity. All right, we'll look at yet another example in the study of molarity.